All right, you guys. Hopefully, you have a TI-84. Hopefully. Obviously, that may not be the case. I want to show you something that I just figured out on my sister's calculator. There is a free app. You may not use this in my class because you can't have cell phones, but at home you can. And it's called Wabbit Emu, which kind of parallels all the apps that are on a TI-83. And because I don't have my TI-83 or TI-84, I'm going to use this tonight to make this video. I'm going to go to the spot that we're supposed to be at. Here we are with a page 4 or page 3 and 4 of the notes for tonight, 1.2 notes. And I'm going to highlight performing a linear regression with a graph of a calculator. What we have is a linear regression is instead of taking an equation and making a graph where we're going backwards. We're taking points and making an equation. All right. So I'm going to read this. I'm going to tell you what's on here. And here we go. I can use a graphing calculator. Ooh, I highlighted the wrong thing. All right. So let me highlight that. You highlight this too. I can use a graphing calculator to model a linear function. There's a lot of skills involved here. It's not going to happen the first time. You're going to have to practice this. All right. When given a set of paired data, X's and Y's, inputs and outputs, you can make a scatter plot to see whether the data shows a linear trend. If so, you can use a graphing calculator to perform a linear regression and obtain a linear function that models the data. Sounds really complicated, but it's not. You should treat the least and greatest X values of the data as the boundaries of the domain. All right, there's a lot we're going to do. So you can use your linear model to make predictions and decisions based on the data. If you make a prediction inside the domain, that means within the data that you see, it's called interpolation. And if you make a prediction outside the domain, it's called extrapolation. All right, so what we have is we have a photographer that hiked through the Grand Canyon. Each day, she stored photos on a card of her digital camera. And when she returned, she deleted some photos from the memory card and saved only the best. The table shows the number of photos she kept from all this stored on the memory card. Using a graphing calculator to create a scatter plot, find a linear regression model and graph the model. Then use the model to predict the number of photos the photographer would have used if she kept 150 photos. All right. So obviously we're going to do something in the data because 150 is somewhere in between here. So interpolation, not extrapolation. All right, we're going to use this one right here. So I'm going to show you this data. It's going to look a little weird, right? Because there's a glare to this that I'm going to have a hard time kind of getting rid of. But I'm going to take that data, and I've actually already put it in here. So here I go. I'm going to hit this Wabbit, and I'm going to hit stat. Same thing you would hit on your calculator. Stat. Except it's not working for some strange reason. Let me try that one more time. Stat, edit. And I have gone, just use these arrow keys, and I've put them in already to save some time on this video. But you're going to see that my data mirrors this. And I'll go ahead and put one in. If you ever want to clear it, you can go up to the top, like that's list 2, and I could say clear, enter, and then I can put them all in. So here I go. It's 25, enter, 31, enter, 39, enter, 52, I hope, enter, 21, enter, 45, enter, and 42, enter. And I think we have it there. All right, and we can see the data. All right, so now what you want to do is you want to do a couple things. All right, I am going to take a look at this, and I'm going to make this into a scatter plot. So I want to make sure my windows match. All right. So my X values, which I'll put right here so you can still see them. All right. My X values look to go, between 100. My lowest is 117. My highest is 188. So I would go to my window, and I would make sure my lowest X value on the screen is 100, and the highest is 200. If I go back, my outputs, my Y values, well, there's a 21. And there's a 52. So I'd go to my window and make sure my y values, I went 0 to 60, which is definitely below 21, and it is definitely higher than 52. If you make your screen big enough, when you graph this, you're going to see a scatter plot, and there's the scatter plot. All right. So the first step over here says make a scatter plot. All right. Now the rest of this is a little tough. All right. We're going to do a linear regression. And before we do a linear regression, we're going to do something that's a little weird. We are going to go second catalog, and we're going to go down to the D's. And we're going to turn our diagnostic on. So I'm going to come down to diagnostic on. I'm going to hit enter, and my diagnostic is on. All right. So here I go. We are going to do a linear regression. In order to do a linear regression, we hit stat, go over to calculate, go down to linear regression and hit enter. And I'm going to hit enter again. And there's my linear regression. All right, that's a lot of data in there. All right. But one of the things you see on here, and I'm going to go ahead, I'm going to come back to this really soon, but I want to show you something. I'm going to show you an R value. This isn't the strongest correlation. All right. And if maybe I didn't put my data in right, but I probably did. So I'm going to show you some stuff on here. I'm going to jump down to this correlation coefficient. All right. And you can see I've written it in. When performing a linear regression on your calculator, you will be given a correlation coefficient R. And that is between 1 and -1. I should have probably written -1 and 1. I should have probably gone from least to greatest. And tells you the direction and strength. All right. If it's negative, it has an inverse correlation. That means the line goes from top to bottom as x gets larger, y gets smaller. If it's positive, it has a direct correlation. That means x gets bigger, y gets bigger. The closer to 1 it is, the stronger the relationship between x and y. That means if it's 0.99999, it's really a linear equation. All right? So, this one doesn't look crazy close. My R value is 0.84. It's not a bad correlation, but you usually want a little bit higher than that. All right. So now, I'm going to show you how to stick this as an equation. So what we're going to do is we're going to go to y equals and make sure that this plot is highlighted. You can go up to it and hit enter, and that plot is highlighted. All right. So now I'm going to go to vars, and as long as we've run that linear regression, it's stored. So I'm going to go down to statistics. I'm going to hit enter. I'm going to go over to equation. I'm going across the top to equation. I'm going to hit enter. And that equation that we just had the calculator figure out is now in our graphing calculator. And there it is. It is a linear equation. The slope's about 1/3, 0.33. My y-intercept's about -11. You can see it right there. And if I graph, here's the graph. If I graph, there it is. We'll see how close it is to those dots. And it's not the best one, all right? But it's roughly equivalent. It roughly touches on these graphs. All right? So that right there is how you create an equation based on a scatter plot. All right. So I am going to save this one. There's another one on here. I would love it if you would try to put this one in and follow all the data I just did. It's going to be a little bit challenging, right? But we will go through this in class as well. There's another data point there. I will walk you through it. But it would be a good idea to get ahead and try everything I just showed you on this video, all 9 minutes, and try to figure this out. I will talk to you guys later.